Okay, here's a complete solution walkthrough to doing turn off the lights using the grid game framework. Here I am in the game board class. This represents our game board. In the constructor, we want to do all of the initialization. So the first thing that we do is create a new two-dimensional int array with this many rows and that many columns. I said that we wanted the lights in the four corners to start illuminated, so we have to assign a value 1 to each of the corners. The left-hand corner is easy enough. That's 0, 0, so I can assign a 1 there. The right-hand corner is probably the most difficult. So the important thing to understand, well, here, let's start this way. So let's assume the grid was 5 by 5. It wouldn't be valid to write this, because remember, all the locations start with 0 in the upper left-hand corner. So if you count up 0, 1, 2, 3, 4, that's already 5 locations. So if I have location number 5, that's 1 past the end of the grid. So this would be the lower right-hand corner. But this is, and then you'd assign a 1 there. But this is not the best answer, because we want our game to initialize properly no matter what size the board is. We can't assume that it's 5 by 5. So we have to use this height and width. So if I know that the number of rows is height, then that must mean that the last valid location is height minus 1. Think about it. If you've got a height of 5, the last valid location is 4. If you've got a height of 7, the last valid location should be 6. So this would be a fine way to do it. Another good way to do it is you could ask the grid itself how many rows it has. This is something that you should definitely know if you're going into AP, but grid.length would tell you the number of rows, and then I subtract 1. The number of columns would be the length of one of the rows. So that would be grid 0. That would give me row, that would give me the first row. And then if I asked for the length, that's how many columns. So this looks kind of ugly, but that does the same thing. I think probably for me the nicest answer is going to be to use the width and height variables. So let's do height and width. So this is upper left-hand corner. This is lower right-hand corner. And now I need the other two. So if I have lower left-hand corner, that's the last row, but it's in column 0. And if I have the upper right-hand corner, that's row 0, because it's the top, but it's the last possible column. So I think this is going to initialize my grid. A good practice when you're programming is to test as you go. So don't just go on and program the next thing. Once you've implemented a small feature, you want to make sure that it actually does what you expect. And that looks pretty good. You might notice that my grid here is 7 by 7 because over in Run Graphical Game, here I'm constructing my board of size 7 by 7. Okay, so far so good. So let's go down to move. I'm going to ignore the bounds checking for the moment, and I just want to tackle some basic problems about like how do I make the grid locations alternate, like turn off if it's on or turn on if it's off. So let's iteratively approach the best solution. So this is probably not the best solution, but I could do something like this. I could say if the row and column where they clicked equals 0, then let's put a 1 in there. Okay, I'm just about to introduce a bug on purpose. It's an easy to make mistake. So if I was going to read this, this reads very much like English. I'm saying if the grid location where I clicked is empty, then, sorry, if it's off, then put a 1 there to turn it on. And if it's on, then put a 0 there to turn it off. But you'll see that if I run the game, it won't actually look like it's doing anything. You can see in the debugging info there that I'm clicking in the rows and columns, but nothing's actually changing. So the bug that's happening here is, well, so if you wanted to actually figure out what was going on, you could put print statements. So changing to 1. And then let's put another print statement in here that says changing to 0. So now we can actually see what's happening as the game is running. So something I'm noticing is every single time I click, it says changing to 1, and then immediately afterwards changing to 0. And that doesn't seem right, because every time I click, I just want it to either change to be on or change to be off, but not both. So that gives me a clue about what's happening. All the center grid locations start off. So if I click in one that's off, that if statement is true, and it says that it's changing to 1, and then we put a 1 in there. And then it keeps going, and immediately it asks this question, is that square illuminated? Is there a 1 in there? And the answer is yes, because we just put 1 in there a minute ago in the previous if statement. So that's the bug, is we don't want both of those if statements to run in a single click. We want to choose, like either it used to be off, in which case we'll do this, or it used to be on, in which case we'll do that. So I think a good solution here is you could have else if, or just an else. If it's off, put a 1 in there. If it's not off, then turn it off. So now I can remove my debugging statements. And let's, in the spirit of testing as we go, let's just test to make sure that works. Great, so I click, and it's definitely turning on and off. So now I need to do the next small piece. If I can turn a single place where I click on and off, can I do the same thing for the neighboring squares? So the square that's above, so if the place I clicked is row column, the location above where I click would be row -1. So I could copy and paste this whole thing, and then make this -1, and this -1, and this -1. So now it's doing the same thing, but for the location above where I clicked. Great, so that seems to be working. Let's make sure that it actually, cool. So when I click here, it's not just blindly turning the square above me on, it's really changing the state. All right, so if we wanted to, we could do this now for the rest of the locations. So if I had row +1, that would be the spot below where I clicked. If I had just regular row column, but column -1, then that would be the spot to the left of where I clicked. And then finally, we could have the spot to the right of where I clicked. So whenever you're copying and pasting like this is a sign that you could be implementing this in a cleaner way. I'm only doing it this way because this is how I imagine you're probably thinking about it. But we'll look at a better way to do this in just a second. Oh, clearly I've forgotten something somewhere here. Let's go back and look. Oh. Boop. Okay, so that seems okay. So we got row column, we've got the one above, we've got the one below, we've got the one to the left, and we've got the one to the right. And that all seems okay. So let's test it again. Okay, so that seems like it's working. Here it went out of bounds, and I'm not worrying about that yet. I'm going to come back and fix those problems later. So I was saying that this isn't the cleanest way to implement it. And the thing is, this is a lot of lines of code, and when you look at this chunk of code, this code block, this is doing a single conceptual thing. We are alternating the light. We're changing the light. But it's actually like 5 lines of code to do it. And so it would be nice if it was visually more obvious that these 5 lines are changing the light to the right of where I clicked, and these are changing the light to the left of where I clicked. So a good solution here is we're really doing the same basic action 5 times, and the basic action is change the light. So let's do this. Let's cut the code, and let's make our own command called change light, where we give it the row that we want and the column that we want. So I can scroll down here after my move method, and I can make my own helper method called change light, which takes a row and a column. I'm going to call it R and C, actually. I'm going to paste the code. So this is the code that checks to see if it's off, turn it on, otherwise it must be on, so turn it off. Only now I want to be operating in whatever the input row column is. So whoever runs this command is going to tell my command which location do I want to change, and then this command is going to change it. So now that I've made change light, everything becomes really short and nice. I can say change light in row call. I can say change light in row -1. I can say change light in row +1, change light in call -1, change light in call +1. And that does all the changing of the lights. If you wanted to, you could actually make all of these into its own method called like change all lights from. So we'll give it a row column. And then here we could make our method, public void change all lights from. And then I'll paste it. And so now we've got one command that will change the light pattern. And that command runs the other command, which will change the individual lights in the individual locations. And now inside move, I just have a single command that does the light changing. So see how we went from a whole bunch of lines of code making a method very large to a couple of very short methods. That's an indicator of clean code. When you don't have a lot of code repetition and you have these kind of cleanly decomposed pieces. All right, so the last part here is I want to check to make sure I'm not going out of bounds. So one thing you might think is, well, first you want to think about when would you go out of bounds. I'm testing the squares above, below, and to the left and right. So that means as long as I'm clicking in the middle here, everything is working just fine. But as soon as I click along one of the edges or one of the corners, it all goes wrong. And by it all goes wrong, I mean it goes out of bounds. You can see that here. So you might think, well, it's only okay to click in the central region. That's not true, though. It should be okay to click in the edge. It's just that if I click in the edge, I only want to change lights that are allowed. So let's see. You could try and put in if statements up here, but the way we've organized it, that doesn't make sense anymore. Instead, it's like before you change any light, you want to see if it's okay. So one thing you could do is this. You could say if, let's see, if I want to make sure the row is in between 0 and the last valid row. So I could have an if statement like if row is greater than or equal to 0 and row is less than grid.length. And the reason I'm saying less than is grid.length is actually one location past the end of the array. Remember, if I have 5 rows, then grid.length is 5, but the last valid location would be 4. So as long as I'm saying the row I'm accessing is smaller than the length, that's like saying my row is still in the boundaries. And let's see, column should be greater than or equal to 0, and column should be less than or equal to the last valid column, or let's say less than the first column where you go out of bounds, which would be the length. So as long as all 4 of those things are true, it's safe to do this. So this is just a way of saying make sure row is between 0 and the last row, and column is between 0 and the last column. And then I would need to have this same if statement right here. Only here, I'm not actually changing row column, I'm changing row -1 column. So row -1 is the location I'm trying to access. So here I'd want to make sure that row -1 is larger than or equal to 0, and row -1 is less than the grid length, because that's the location I'm trying to change. So you could do this. You'll notice that this looks kind of ugly and hard to think about. So a nicer thing to do is, again, let's make our own helper method. Is in grid. Oh, look, it already exists. Is in grid. So what I really want to ask is the row and column in the grid? So you can say, if I'm trying to change a light at row column, you can ask if the row and column is in the grid, and if that returns true, then I know it's safe to do it. So now I can just modify this by saying is in grid row -1 column, and now I'm asking if row -1 column is in the grid, and so on. But we have to write the isInGrid method, so let's go down there. This is at the bottom. So here I can have that same kind of if statement. I'm asking if this row and column is in the grid, so I can still have this if statement. And I can return true if it's in the grid and false otherwise. For people going into AP, note that this entire thing evaluates to true, or like if this entire thing evaluates to true, I'm returning true. If it evaluates to false, I'm returning false. So it's actually even shorter just to directly return the result of that Boolean expression, like this. For other people, if that doesn't make sense, don't worry about it. It's just like a little bit shorter. But the other if statement is just fine. So now I've got this nice method that will tell us if a location's in the grid. I was using it up here. But again, this is making it look kind of longer and harder to read. Maybe it doesn't make sense to check if it's safe and then do the operation. Maybe let's do the safety check right in the same place where we're telling it to do the operation. Maybe I should have my safety check be inside the changeLight method. So let's go there. Here's changeLight. I'm going to try and change RC, but let's add the safety check here. If is in grid RC, then I can make the change. Otherwise, I won't do anything. If this if statement, let's make equals true. If this if statement doesn't evaluate to true, that means we're trying to change a location that's not in the grid, and we don't want to do that. So we'll just go to the end of the if statement, and the method exits without doing anything. So look at how cleanly this is broken down now. Inside the move method, we're running this one command to change the lights. For each change the light command, we're telling it which light to change, and then the change light command itself decides whether or not it's safe. All right, so let's go ahead and now test it. So we already know that in the middle here it's safe, but now you can see that in the edges and in the corners, I'm testing all 4 corners and all 4 edges, and we see that no matter what I'm doing, it's not causing me to go out of bounds. All right, so last step, we gotta test to see whether or not we've won the game. And we've only won the game if all of the locations are off. So let's go way down to the bottom here. Where is it? Is game over. So I want to test if every single location is off. Don't try and have an if statement that tests each location by itself, like if grid 0, 0 equals 0, and grid 0, 1 equals 0. There's a bunch of things that are wrong with this. First, it's going to be a lot of if statements, and that's kind of difficult to type, and it's gross. Another reason is it's not flexible. Remember that we actually don't know the size of our game board, or rather, the size of our game board might change each time someone runs the program. So we can't assume that it's only 5 by 5. It's whatever width and height are. But the problem with that is, if you were going to test each location separately, you don't know in advance how many if statements to type. So that's why you use loops, because if you're looping over all the locations, you can say start my location at 0 and go all the way up to the last location. So the pattern that's in the handout is I'm going to start my row at 0, and I'm going to go all the way up to grid.length. So this is saying let's loop over all the rows. And now I'm going to start at column 0 and go up to the length of whatever particular row we're in right now. So R is a number, right? Might be 0 the first time through. So now this is saying let's look at the grid, and let's look at whatever location row we're on right now. So this might be grid 0, and then let's ask the length of grid 0, which is the same thing as the width of that row, which is like the number of columns. So this says for every single row, loop over every single column in that row, and now I want to do something. So often it's easier to test for a bad condition than it is for a good condition. And what I mean is, we're trying to test if the game is over. And the game is only over if all the locations are empty, if all the locations contain 0. But if I test if a location contains 0, if I test if RC is 0, I haven't won yet because this is just one test. So I can't conclude anything yet. I have to wait until this whole thing is done looping. So this actually isn't very helpful. One thing you could do is make a counter, which is going to count how many locations are equal to 0. And then at the end, you could say, like, if the count is the same thing as the width times the height, then I know that they're all 0. But there's an easier way. Think about a test you could run where you could immediately come to a conclusion about whether or not the game was over. If I ever see a light that's on anywhere, I know immediately that the game is not over yet, and I don't even have to check any other lights. So that's what I mean by testing for the bad condition. I'm testing for a condition where I know I could immediately exit with a failure. So if I'm asking as the game is over, I'm going to loop through all the locations, and if I see a location where the light is on, then I will return false because I know the game is not over. And remember, as soon as you hit a return statement, this method immediately exits. I don't keep looping. At the very, very end, if I ever reach down here, I know that I've looped over every single location, and this if statement was never true. Because if that if statement were true, I would have exited already. So the fact that I'm down here now and I never exited means that I've looped over all the locations and all the locations contained 0. Or at least none of the locations contained 1. And so that means it must be safe to return true because I know that I didn't see any lights on. So this is the most flexible version of is game over. How would you test if the game is over? Well, one thing you could do is win the game. Another thing that you could do, which would be actually pretty easy, would be let's modify the game temporarily for testing purposes so that inside change light, I just turn the light on and that's it. So let's say grid RC equals 1. And now when I run the game, I can just turn all the lights on without worrying about toggling. And that'll let me see if the game is over. Oh, except I'm not really testing it yet because I completed that method, but I don't think I'm actually running that method anywhere. Okay, but you see it's very easy to... Oh, I turned them all on. I should have turned them all off. This is the problem with trying to talk and think at the same time. Okay, here we go. So, oh, all right. So what I'm really trying to do is turn them off. So I'll do that. And then just for testing purposes, let's do this. I'll say if is game over is true, then you win. All right, so now I can actually do a proper test. Here we go. Okay, I'm going to turn it off, 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 and it says you win down there. So I know that that's worked. All right. So that was my walkthrough of a solution. I hope that even if you were able to complete the game, you learned something new. If you have any other questions, please let me know.